So electronegativity is the tendency to gain electrons. And when we talk about a polar molecule, if we have two atoms, find out which one has more electronegativity. That will be find out by how? You're going to find out by looking at the periodic table. The atom which is on the most right and the uppermost will be more electronegative, and that atom would get a slightly negative charge, or we call it a partially negative charge. And this is only when we talk about covalent non-metals, because non-metals आर ऑलवेज अनचार्ज कोवेलेंट का हमने हमेशा से सुना है जीसीएससी कि वो अनचार्ज होते हैं आयोनिक में भी नॉट लुकिंग एट इट बिकॉज आयोनिक में वी आर ऑलवेज कंफर्म परमानेंट पॉजिटिव आर द मेटल्स और परमानेंट नेगेटिव चार्ज हमेशा नॉन मेटल्स के पास होता है यहाँ पे अब दो नॉन मेटल्स हैं कोवेलेंट है सो द मोर इलेक्ट्रोनेगेटिव वन वुड गेट अ नेगेटिव वन और उसके करीब वो बॉन्ड पेयर हो जाएगा द बॉन्ड पेयर वुड बी क्लोजर टू द मोर इलेक्ट्रोनेगेटिव वन and the less
Yeah.
electronegative one would get a partial positive charged. Is it clear till now?
Yep.
Good.
Hi and welcome back to Free Science Lessons. By the end of this video, you should be able to describe how a bond or a molecule can be polar. In the last video, we saw that different elements have got different electronegativities. Electronegativity is the ability of an atom to attract the pair of electrons on a covalent bond. We saw that the most electronegative elements were at the top right of the periodic table. I'm showing you here the chlorine molecule Cl2 and the hydrogen chloride molecule HCl. Looking at the chlorine molecule, we can see that both atoms in this molecule are chlorine, so both have the same electronegativity. Because of this, the electron pair in the covalent bond lies midway between the two nuclei, and scientists call this a pure covalent bond. However, in the case of hydrogen chloride, the electron pair is much closer to the chlorine atom than the hydrogen atom, and that's because chlorine has a greater electronegativity than hydrogen. Scientists call the separation of charge a dipole, and the covalent bond in hydrogen chloride is described as a polar covalent bond. The covalent bond in the chlorine molecule has no dipole, so this is an example of a pure covalent bond. Now, there are two ways to show that a bond is polar. The first way is to write delta positive and delta negative to show the charges. Delta means that the charge is small, and that's because the electron pair has only shifted towards the more electronegative atom. The delta negative sign will go on the more electronegative element. The other way to show bond polarity is to draw an arrow like this, and the arrow points towards the more electronegative element. Now, because hydrogen chloride only has one bond, and that bond is polar, this means that the hydrogen chloride molecule has an overall polarity. Scientists call this overall polarity the dipole moment. But what about molecules with more than one bond? I'm showing you here the molecule carbon dioxide. Carbon dioxide has two carbon to oxygen double bonds, and both of these bonds are polar. However, these bonds point in opposite directions in a straight line, so that means that the dipoles cancel each other out. Because of this, a carbon dioxide molecule has got no overall polarity. We can see the same idea with this molecule. This is called tetrachloromethane. This molecule has 4 carbon to chlorine bonds which are polar. However, the molecule is symmetrical in all directions, so these dipoles cancel each other out, and this means that this molecule is non-polar. This molecule is called trichloromethane. The carbon to hydrogen bond is effectively non-polar, as carbon and hydrogen have got very similar electronegativities. In this case, the dipoles on the carbon to chlorine bonds cannot cancel, so this is a polar molecule. The side with the hydrogen is positive, and the side with the chlorines is negative. Okay, this shows a water molecule. Water contains 2 hydrogen atoms bonded to 1 oxygen, and these bonds are polar. The water molecule has a non-linear shape, so this means that although these 2 bonds point in opposite directions, they are not acting in a straight line. Because of this, the bond polarities cannot cancel, and this makes water a polar molecule. In the next video, we'll start looking at intermolecular forces.
All right, is it clear? Got it? So now that we have talked about what are polar and non-polar molecules, next we'll talk about metallic bonding. What is metallic bonding? The nature of metallic bonding, अगर हम discuss करें, metals typically have the following physical properties, including high melting temperatures, good electrical conductivity, good thermal conductivity, malleability, and ductility. Any theory of the way that the atoms in a metal are bonded together must explain the above properties. Metals typically have 1, 2, or 3 electrons in the outer shell of their atoms, and they have low ionization energies. The electrical conductivity of a metal generally increases as the number of outer shell's electron increases. Since electrical conductivity depends on the presence of mobile carriers of electric charge, we can build a picture of a metal as consisting of an array of atoms with at least some of their outer shell electrons removed and free to move throughout the structure. We call them the delocalized electron. Any ion, हो अगर आपके पास you have magnesium, calcium, each ion loses 1 or 2 or 3 electrons, and those electrons are now becoming a part of that structure. We call it the delocalized electron. For example, if this positive ion is a sodium ion, sodium 8 would be surrounded by 1 electron. If that
Mm-hmm.
positive ion or that structure is of aluminium, there would be a lot of aluminium atoms and each of those aluminium atom would have lost how many electron? 3, 3 each. Because aluminium is in group number 3. If it
So
was
we have three
magnesium,
atom of shell
magnesium being in group
electrons.
number 2 would be losing 2 electrons, and those 2 electrons will be known as the delocalized or free electrons. And
Yeah.
these delocalized electrons are largely responsible for the characteristic properties of these metals as well. Here you can see the structure. The electrons are said to be delocalized since they are free to move throughout the structure and are not confined localized between any pair of cations. There are electrostatic forces of attraction between the cations and delocalized electrons as well. This is known as metallic bonding. So if we explain the property of metals, now we're going to discuss each and every property of metal and their reasons. Melting temperature. We know that metals have very high melting and boiling temperature, and in order to melt, it is necessary to partially overcome the forces of attraction between the cations and the delocalized electron to such an extent that the cations are now free to move around the structure. Metals have a giant lattice structure where many of these forces must be overcome. The energy required to do this is usually very large, so the melting temperatures are typically high. So what are the reasons that you're going to write if you're asked that why is the melting temperature of any metal high? Because a lot of heat, energy, or temperature would be required to
Mm.
overcome the forces of attraction between the cations and the
Electron.
delocalized
And
electron. And I need the
yeah.
complete answer. If I don't get a complete answer in any of your paper, you're going to get 0 marks. The number of d elect
Cations are positive, right?
yes,
Cations are positive, right?
yeah, obviously.
Okay.
The number of delocalized electrons per cation plays a part in determining the melting temperature of metal. Group 1 metals have low melting temperature, group 2 metals have high melting temperatures. Metals in the D block typically have a high melting temperature because they have more delocalized electrons per cation. And another factor of obviously अगर आपके पास group 3 metals होंगे, they would have the highest melting temperature. Why? Strongest force between the cation and the electron, because group 3A metals जो होते हैं उनके पास तो तीन तीन delocalized electron है. Each cation would have 3 localized delocalized electron. Another factor that affects the melting temperature is the charge to radius ratio as well. Greater the charge to radius ratio, stronger the attraction. Smaller size होगा तो ज्यादा attraction होगी. Electrical conductivity, why? What is the reason why metals are electrical conductivity? Why do they conduct electricity quick?
Sorry, I was muted. They have delocalized electrons which will attract.
Exactly. Simple. Thermal conductivity, because of the free moving delocalized electrons and that the cations are closely packed as well, so they can pass kinetic energy from one cation to the other. And why are they malleable and ductile? Can you tell me?
Because they have it's also because of the electrons which allow them to move through the metal.
What?
The decolorized electrons will
No,
move through the cations.
they can slide over each other. There are layers.
Yeah,
Ductile means what?
sliding. No.
Ductile means to bend. Haven't I sent you the lectures? You don't revise, you don't read anything. Then what about this piece of metal? It is compressed to a sheet. We call this malleability.
Yeah,
Ductile is bending and compressing into sheet is known as malleability. Got it?
malleability. Yep.
However, because the delocalized electrons are free moving, they move between the cations and prevent the strong force of repulsion forming between the cations. अब होगा क्या, when they slide over each other, positive के सामने positive आ जाता है, so now they can be broken down, bended or compressed very easily. Clear?
Yep.
Good. And that is the end of your topic number 3D as well.